All right, so this is the follow-up to what we started in class. So I'm actually going to back up a little because I want to make sure you're comfortable with your calculator and that we can go back to the first example and you can see some of the different things you can do with the first example with your calculator. We're going to do the same thing for example number 2. So I am going to, if you ever want to know, again, a quick way to clear what you have, press Menu, go to Actions, and then Delete All, and you'll have to press Enter to say, yep, delete everything. That way you can clear everything up. To start an equation, once you're there, press the Tab button. So I'm going to press the Tab button, and that allows me to type in the first equation. So I'm actually not going to type in the integration. Instead, I'm going to type in what's actually given in the question, x squared plus 2. So I'm going to go x squared plus 2, and then I'm going to graph it. That's a good window for what I need. If I need to change the window, I'm going to go to Menu again, and then I can change the window to what I need it to be. I want another equation, so I'm going to press Tab again, and that gives me a second equation on the same graph, and this one's just y equals x. You can see that these two things do not intersect, neither do they in our notes. On our example here, they don't intersect, but it doesn't matter. And then, how do you find the area between those two, right? The parabola and the line using our calculator. So we're going to go to Menu, we're going to go to Analyze and Graph, and we're going to go to, it says Bounded Area, which is 8. And then we're going to move. Now you can move it with the touchpad, or you can put in the numbers. So I'm going to put in the numbers, 0, and then Enter. And then the second, the upper bound was positive 1, and Enter. And then it will find the area. Do you see that shaded part there? The area between the parabola and the line. And it was 1.833 repeating. And that we knew that was 11 over 6. All right, so it's good to know that you have that skill. If I went to number 2, I'm going to switch over to the scratch pad where I can type in. So I press the scratch pad, the shaky calculator, so I could get over and calculate. But here, let me actually do this first. If I wanted to graph this, I would have to write the equation, graphing like, I would have to write the equation in terms of y equals if I had to use my calculator. So if you do in terms of y equals from the beginning, you would have to use positive and negative root x plus 3. Let's just see what that would look like. So with our calculator, we can only type it in terms of a function. So a sideways parabola is not a function, so we're not going to graph it that way, but we write it as a function, positive and negative. So again, if I go to this graph, how do I erase it again? So go to Menu, Action, erase all of it, press Enter, so it's all gone. Press Tab, and I'm going to type in y equals x plus 1. I'm going to type in y equals root x. So root is here, Control x squared. Oh, I need to press Tab first. Let's do it again. So Control and x squared gives you the square root. That's x plus 3. It's good to practice this. There's 1. And then I'm going to press the Tab again for a third one, and now it's going to be negative. Now that negative is not the subtract sign. It's the negative under the 3. Then Control and x squared, and again we're going to type in x plus 3, but with the negative in front. We're going to graph it. And so do you see the top half and the bottom half and all of that? All right. Now, how do I integrate the bounded parts with this with our calculator? So I'm experimenting here too because we have 3 functions going on. So let's see if this video works out. So we're going to go to Menu. We're going to go to Analyze. We're going to go Bounded. So the first bound I'm going to go is I notice it's bounded on the left. Remember, I got to use x values here, not y values, because it's in terms of a function. So x values, the upper and lower. So the lower bound is at negative 3. Oh, they want to know which graph is what. So if I go from here to here, so let's see. Will it find me the area in between? So will it calculate it for me with the three different functions going on? Notice there's an overlap there in area. So it becomes a little more challenging with the graph. It's a good way to know which is right, left, top, bottom. It's a good way to know how to graph. But in terms of actually finding the area of the shaded part when it's not in terms of a function, and that when there's three functions going on, then it's challenging. We would actually have to separate this into two functions and go top, subtract, bottom in terms of two functions. But I'm not going to do that right now. So how would you find the points of intersection if I wanted to do that? So if I went to Menu and Analyze, you can see intersection is 4. So then it says which is which graph. So if I want this graph, in the second graph I highlight over it and press it, and then I say, okay, what are the bounds? So the left, enter, and I move it to the right of where it intersects, enter. See that point in the middle? It's going to find that point of intersection, and notice it gives me the point. Now if I can't see it, I can actually move that point, so grab it with your hands, click enter again. Oh, see if I can release. There we go, press enter to release it. Now you can actually see it's -2 and -1. If I want to find the other point of intersection, Menu, 6, intersection. Now you have to identify what the two functions are. So again, the function here is the line, and it kind of goes bold. Hover over the other one, and it goes bold. There's the second one. Then it wants to know, there could be more than one point of intersection, right? So it wants to know what are the bounds I'm looking for, the lower and upper. So it means left, then right of the intersection. So anywhere to the left of where it intersects, press enter, and then the intersection to the right of it. So notice the shaded part covers the point I'm looking for, enter, and then it gives me that point. So I'm going to move the hand away, and you can see the second point of intersection is at 1, 2. So that might be a helpful tool with the graph. You can also find points of intersection using the algebra function on your regular scratch pad. So if I press sketchpad and I went to Menu and I went to algebra, and it says to solve a system, which is 7. And so solve a system of equations that are linear, that's 2. Well, one is linear, right? The other one's not linear. So here, let me go back. Control, escape, back. Control, escape. Here. Let me go back again. So I'm going to erase this. Or maybe you'll still solve it. Well, it says linear. So I think like 1, because 1 is not linear, let me delete this. Let's try it again. So let's go to Menu. Let's go to Algebra, which is 3. Let's go to 7, solve the system, and then 1. So it's solving the system. How many equations do we have? 2. What are the variables? X and Y. So we could change that if we wanted to. Press OK. The top equation was x equals, and you can type it that way, x equals y squared minus 3, and then move it to the bottom, and the second was y equals x plus 1, and then press enter. So notice that you get your points of intersection. So x is -2 and y is -1. There you go. X is 1 and y is 2. There's your second point of intersection. So you can solve this system algebraically or with your graph. You need to know how to do both. And the only way you get better with this Ferrari is to practice. And to practice with me. Anyway, so I went back to 1 and 2. so that you understand how to do that when it comes up. We might do it again for more examples. Let's look at example number 3. It says, and again, if I went too quickly with the calculator, all you do, of course, is press pause and make sure you know where the buttons are. And if you have more questions, come in at lunch or whatever, or even in class, and we'll figure out how to set things up. It says, set up integrals for the total area of the regions located between the two curves, as shown. It says you may use a calculator to do it. So first of all, I still need to show the setup to understand this. So the setup to understand this is to understand that we have two functions. So nothing sideways. The bounds are going to be upper and lower. This is what we need to understand, is that at first one becomes above and the other one is below. The second, the one goes above and the other one goes below. So what we know here, the left part, which function is on top, which one's underneath. So the curve is on top, so the x cubed minus x squared, and the parabola, which is this second one, concave down, negative x squared plus 41x. So can you identify the parabola and the cube function? That's important. So for the first section, this is going to require two integrations if we write it out by hand, because it takes turn which is on top and which is on the bottom. This point of intersection, this point of intersection, this point of intersection. All of them are important. So if I have my calculator and I need to solve for this, we're going to do that in a second. We need to know how to find the area with our calculator. So what would the setup be? So this point down here, whatever that value is, let's call that x value p, because we don't know it's negative 2. It's close to negative 2. And this one up here we don't know. Let's call that one q. The setup would go from the upper to the lower. So the x value here is at 0. That's a point of intersection. And it goes to whatever that x value is, which is p. And the upper curve is x cubed minus x squared. Subtract the lower, which is the parabola, negative x squared plus 4.1x. Use parentheses, especially when we're going to use our calculator soon. Make sure that we do it correctly. Plus the second one. The second one is going to go from 0 to q. And again, this time the upper one, upper subtract lower, is the parabola. So now it's negative x squared plus 4.1x is on top. Subtract the bottom curve, which is x cubed minus x squared. And this in terms of dx. So that's like the general setup, right? And we have to have two because in one bound we have an upper and lower. But then when we go to the next one, it changes which one's on top and which one's underneath. That means that we need to understand all these points, the ends, as well as the point where it changes, where which one is on top and which one's on the bottom. All right, let's type this in our calculator. I want to show you a few things. First of all, we're going to go back to the graph. We're going to clear what we did before. How do we do that again? So we're going to go to Menu, press 1, press 4, and then, yep, I want to erase everything. Then I'm going to press the Tab button, and I'm going to type in the first one. Now, the first tab is x cubed. Move the cursor. Subtract x squared. We're going to graph that. If you had to, you might have to change the zoom, right, so that you can actually see it a little bit better. Like, it's really hard to tell here. I might zoom in and do the same window. Notice, like, on the picture is given, what's the x window? It goes from negative 2 to positive 2, about. So I'd like, if I change the window, go to Menu and the window, And if I wanted to do the window settings, my x minimum, I'd actually make -3, so it's 1 less than what I need. The x max, I'd make +3. The y minimum goes down to -12, so 1 less than that. Go down lower, would be like -14, more than what you need. And then the y max up here is at 4, so I'd go up to like 5 or 6. So that you could change the window, and I change the window based on what I see there in the actual question, and then click on OK. Now we need the second part. So there's the first part. How do I type in a second equation? Is I press tab again. This time I'm going to type in x squared, -x squared, and plus 4.1x. You need to bring your calculator to class, those that don't. All right, so can you see now the two graphs that we're able to do and how they match what we see? All right, that was security looking for somebody, but there's no one in here. So we have the two graphs. Now can you find the area that's bounded between them? So I haven't done this, so I don't know if we'll have to do this in two parts or not. So let's do that. So menu, let's go to Analyze Graph and Bounded. That's 8. Then it says, what should the lower bound be? So I'm going to estimate, what would that lower bound be? And does it know what the lower bound should be? Automatically. So here, I'm going to go way left. Well, let's see what happens here. So the lower bound compared to the upper bound. See if I go, see if I go too far right, what happens is it shades more than I want it to shade. And I don't want it to shade all that, and then press enter, and then it finds the area that went beyond what I needed. So I didn't need that little area on the bottom left. I don't need that area on the bottom right. So what do I need to do first? Well, I'm going to go back. I'm going to try to press Control Escape. So if I press Control and then Escape, it undoes that. So obviously what I need to find are the points of intersection. So how do I find that to begin with? Go to Menu, go to Analyze, go to Intersection, which is 4. And again, it's going to ask for the lower and upper and lower bounds. I'm going to go way left, more than I need, way right, more than I need, and it's going to give me that point of intersection that's right there. So I want the x value, which is -2.02485. I'm just going to carry all those decimals. And I'm going to write it down. So -2.02485, all of them. Then I'm going to do it again. I'm going to go Menu. I'm going to go Analyze Graph. I'm going to go to Intersection again, which is 4. And again, I want that upper intersection. So to the left, press Enter. Move it to the right of it, way right, make sure it covers it. Enter, and then what's that second point of intersection? What's the x value you see there? That's positive 2.02485. All right, so now we have our values. So now I can integrate from bound to bound using those x numbers. So notice I wrote down those bounds, -2 to +2. So now I actually know what p equals. So this is what p equals. And this is what q equals. So for my setup. So if I had to write the setup as well as use my calculator, I make sure that number goes in for P and that number goes in for Q for the setup. All right, now let's go back to our calculator. what's the setup going to look like now? So again, I'm going to go Control Escape to get rid of the points of intersection. I'm going to go to Menu, and I'm going to press Analyze Graph, and I'm going to press 8 for bounded area. And so what's my lower bound? I'm going to type in negative 2.02485, and then press Enter. And then it says upper bound, and I'm going to just type in what the upper bound is, 2.02485, enter. And now look at the picture. Can you see how it goes from bound to bound properly? The right areas are shaded. And most importantly, I need to know the answer. So the answer is right here. Let me move that for you. Oh, it's 8.405, but you know, you can grab it. No, you're doing that to me. Let's try it again. So you can grab it. I got to practice. Maybe Enter would grab it. No? Or double click? So let's try it again. So if I wanted to grab it, there it sits. I just have to hold it down. And then wherever I want it to be, hold it down, it lets go. So you just got to press it down for a while. I need to be patient with it. So what is the area bounded? 8.405. If you are asked for only the setup, so actually example number 3, it just asked for the setup, you would just write this down for the setup and know that what P equals and what Q equals, you would then put in what those numbers are, negative 2.02485 and positive 2.02485, and put them in for P and Q as the setup. There you go. All right, turn the page. It says discovering the formula for the average value of a function. The average value of a function represents the average height. Another way of thinking of it is, what's the average y value as you go from one bound to the other? So if you look at the y value all the way through, what's the average y value from A to B, or the average height? So draw a horizontal line segment from x equals A to x equals B. So between A and B, I'm going to draw a horizontal line segment which could represent the average height. So something in the middle, like here. So draw a horizontal line that could represent the middle of that. So you have as much above as below, a middle part, a horizontal line. It says find the area of that rectangle that was formed. So this rectangle that was formed goes from what's the width and the height of it. So the width would be B subtract A, right? The upper minus lower bound. And then whatever that height was would give you the area. Then it says when you integrate that, can you now solve for the average height? So from A to B, how do you find the area of what I just drew in terms of from A to B? And you integrate from A to B. And that's equal to B minus A times the height. So the question is, what do you think the height represents in terms of that? B minus A. So if I integrate from A to B, f at x dx, I have to then divide, this is off my screen, I then have to divide by the difference of the bounds. And that gives me the average height. The formula is down here below. how do you find the average value? That's the average y values. Is you integrate what your bounds are, and then you subtract by how big the area you looked at, or the width of the region, by going b subtract a. You could also have 1 over b subtract a, that fraction, in front of the integration. Because really that's just a constant, 1 over b minus a, and you could also write that in front, and then do the integration. And that can be helpful actually too. So example 4, find the average value of this function. So what am I asked for average value? What's the average y values? What's the average output? So if you looked at every single y value in that bound, what's the average y value in that one? So we're going to go from 0 to 2. So first of all, what's the width of our bound? How would I find that? The width of the region from 0 to 2? I would just go 2 subtract 0. So 2 subtract 0 is 2. And that's going to be my denominator. And it's okay to practice that. Being the denominator, you can actually put that as 1/2 in front. Then we're going to integrate from b to a, or from a to b. In this case, it's from 0 to 2, and then you integrate the function, and it's x cubed minus x. That means the same as from 0 to 2, x cubed minus x, and that should have a dx here. They're equal to each other. But it actually is nicer to integrate with a 1/2 in front than having the 2 in the denominator. So I'm going to stick with the 1/2 in front. So with the 1/2 in front, I'm going to use brackets or parentheses. Could you integrate x cubed minus x? So add 1 to the exponent. It's x to the 4th divided by 4. This becomes minus x squared divided by 2. And we're integrating from 0 to 2. And then close it. So keep going. The 1/2 in front, bracket. First we plug in 2. So it's 2 to the 4th over 4 minus 2 squared over 2. Close it. Subtract. Now plug in 0. Well, if I plug in 0 and 0, the answer is going to be 0. And that's it. And you can solve it from there. So let's simplify it fully. 1/2 in front. 2 to the 4th. 2 times 2 times 2 times 2 is 16 divided by 4, which is 4. 2 squared is 4 divided by 2, which is 2. So 4 take away 2 is 2, and then 1/2 of 2, the answer is 1. What did we find again? The average value of that function. That means that positive 1 is the average of all the y coordinates. So if you took every single y coordinate from 0 to 2 for x, the average y value is positive 1. All right, let's look at it again. This, I think, is our last example. And then you get to practice and ask me questions on Tuesday. Okay, use your calculator to find the value of c in the interval from 0 to 2, where the f at c, that's the y value, the average value found in example number 4. So we said the average y value was what number? Positive 1. So what's the x value that goes with that y value? That's what it's asking for. C represents the x value when y is equal to 1. So how do I find the x value when y is 1? So at what point do you find that average value? So what does y equal again? Up here, x cubed minus x. And we want to know when that is equal to what number? 1. So y equals 1. Or y is x cubed minus x equal 1. How do I solve this? Well, use your calculator. It would be tempting because you could try. It's a polynomial, so it's nice to make it equal to 0 and solve. This is not obviously factorable to try to find it, so there's not a way to solve it by hand would be challenging. So how would you use your calculator to solve it? I love the ability to keep going back to your Ferrari. To be able to solve it. So I'm going to back to my calculator. How do I get off this graphing part? Is I press the shaky calculator button. That's the scratch pad. And then how do I solve an equation? Is I press menu, I go to algebra, and then I go to solve. That's 1. And then what am I going to type in? X cubed, move the cursor, subtract x, subtract 1. Now that's not enough. We got to make it equal to 0. Still not enough. Comma. Remember the comma is underneath the pi. It's way down here in the bottom left. Whoa. So the comma is underneath the pi. The comma tells the calculator what letter to solve for. So comma, and then come back here. Put in the letter x, because that's what you're solving for, and now you're ready to press enter. Enter. What? Oh, let's move the cursor over. Did it freeze on me? Oh, it has like this little fun little clock going on. It's spinning. Oh, there you go. I just had to be patient. So what is x equal? Is 1.23 and so on. Now, in calculus for the AP exam, we're practicing that you should at least round to 3 decimals, even if you're not told. So the answer here would be x equals 1.32472. So it's okay to truncate and just put 1.324 as your answer. Or you can add more decimals. It's important to know that this x value is inside that domain restriction from 0 to 2. Let's say there was more than one x value. Let's say that the answer was 1 point something, negative 1 point something, negative 10. You'd have to pick the answers that are in your bound from 0 to 2. And that is in there. So there's your answer. All right, I need you to do your homework. We're getting into more challenging material now in terms of the beginning of the unit. So, and the next one's going to deal with volume and cross sections and all kinds of interesting things. So we got to stick together on this. So do your homework this weekend. Practice with your calculator. Be prepared on Tuesday to ask me whatever questions you want so that before I give you the quiz you feel ready. All right, have a great weekend.